Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, today we have a special guest, Cedric Beust, who we have known for a really long time. And he was listening to one of our episodes, or I think all of our episodes, but had some great discussion points about some of the topics that we talked about around Kotlin and Monads and some other things. So hi, Cedric. Great to have you.
Hi, James. Hi, Bruce. It's very happy to be here. Yes, it was very hard not to react because I know you guys have been touching on things that are dear to me, and I really enjoyed my reaction. Sometimes agreeing, sometimes disagreeing, or in my car or while running. And I thought I need to talk to this guy. So here we are.
Here we are, and that's how we grow and learn is to be challenged and hear other perspectives. So it's great to get your perspective on this stuff.
Yeah. So why don't we start by, not everybody who's listening is going to know who you are, so we should find out who you are. But one of the things I think I noticed is you were on the C++ standards committee for a while, right?
That's right. That was a long time ago. I don't know how you were able to dig that up, but
well, I don't know. I looked around, and do you remember because I was on it for the first 8 years. Do you remember what years you were on it?
Yes, I was there around maybe 90, let's see, it was during my PhD, so between 93 and 98, 99, something like that.
Yeah, it seems like we would have crossed paths then, but there were a lot of people there at...
I was a fly on the wall. I was mostly listening and just not participating, but just hearing from all these very, very smart people and getting a chance to meet and talk to Bjorn Strastrup and all the others.
Yep, that's why I was there. I think I made one contribution, and it was tiny, and I don't even remember what it was.
And I think at the time I had already moved to a Java mindset. I started using Java in 95. And so but after 1 year of doing Java, I knew that I didn't want to go back to C++. So my interest into C++ waned around that time. But it was still intellectually exciting to see where they were going, because it was really a good way to observe the process and how they were making all these decisions. So there was still a little bit of interest in me. But using the language by then, I had lost interest.
Yeah. No, I mean, it's done some really interesting things since then. I mean, I think they've either taken cues from Rust or they were working on it already. And so they have much nicer memory management with their smart pointers now. So
I have a tremendous amount of respect for everyone who works on C++. It's not a language for me now, and it hasn't in a while, but I still respect the language and I still respect what it's trying to do, and especially all the constraints that they have to work with. And I think a lot of people look at the language and just have a cursory judgment saying, oh, it's ugly, and they don't really understand what's behind it and all the smart that has to be put into it.
In order for backwards compatibility with C. Yeah, that's what people don't understand, is the reason that it has its dark corners is so that you could just take your C code and compile it under C++, and that took a lot of effort.
Mm-hmm.
So anyway, give us, you've written a couple of books, and you've built a build system, and you've created a bunch of other things. So tell us about that stuff.
Yeah, I've been on the Java scene for around 95, so around 25 years now. I fell in love with the language right away, and I'm trying to be active as much as possible. And I got a chance to influence the language a little bit, working with Josh and a few other people on some JSRs, and I released a few libraries that have picked up some momentum, some of which I'm still working on. But like you, I switched to Kotlin a long time ago, though. I think I trace back the first blog that I wrote about Kotlin was in 2010 when JetBrains announced it. And I started participating right away because I fell in love with the language right away, even in the early shape that it was in. I thought it was really a perfect alignment of, if I wanted to create a language, well, now I don't see the point because JetBrains is creating it and they have all the right mindset. So I've been interested in Kotlin for a very long time, and I started writing a lot of it in anger, I would say maybe 5 or 6 years ago, where I started writing libraries and real code. So, and I've been in love with it ever since. And I don't fall in love with languages a lot. It's every 20 years or so, I think.
Yes. So yeah, in fact, I think when researching Atomic Kotlin, I've ended up reading a number of your blog posts when I was hunting for answers. So that was very helpful. Thank you. Well, so yeah, so you've been using it for a long time. So tell us what you love about Kotlin.
Well, I think basically Kotlin addressed all the pain points that I had in Java. I've really enjoyed Java for a very long time, and I thought it got a lot of things right, especially coming from years and years of suffering with C++. It was a breath of fresh air when I switched to Java. And I felt the same with Kotlin. I think Kotlin addressed a lot of the pain points that I felt with Java. Java never felt as oppressive as C++ did. I was still pretty happy with Java, but a lot of the things that I wanted Java to move into a certain direction, Kotlin right away did it, and I started interacting with the team over there, and they were, first of all, so open-minded, really creating the language, getting a lot of feedback, getting their reasoning from a lot of books and articles and good practices, and then having very interesting discussions. But overall, I felt we were very philosophically aligned in what we thought needed to be fixed, in what we thought needed to stay the same way, in what we thought needed to be changed a little bit. And it's been really a pleasure to see the language evolve in pretty much the exact direction that I wanted.
Yeah, my feeling was that rather than me discovering something and wishing that they would fix it like I did in a lot of things in Java, I was not as happy with Java as you are. I felt like Kotlin anticipated a lot of my needs and desires and did it ahead of time. So
yeah, it was a love at first sight for me. First of all, one of the things that you touched on in one of your previous podcasts was properties, for example. To me, it's the number one pain point of Java. It never comes up when people are asked, "What is your main pain point?" It's never properties. People don't seem to think about it much, but when you've written tens of thousands of getters and setters in Java, and you can start using properties, whether it's Groovy or Scala or C# or whatever, you really want them on a daily basis. And I've talked to Brian for years over this, and I understand his reluctance. I understand why he's not a big fan of it, and he's not going probably to include it. But I really wanted the language to do that. So Kotlin had that. And then plenty of other things, the syntax for the constructor. Now when I see a constructor in a class taking multiple parameters, and then you have the body of the constructor, and you assign every parameter to the field one by one, all that. And I see that, I think, come on, Scala did it right here. I'm glad Kotlin followed suit, and Groovy as well. This is the way it's supposed to be. We're beginning to converge into some very well-accepted good practices of what a modern language should look like. This is the starting point to have concise code. We don't need to do all these copy-paste and things that is so repetitive.
Yeah, and when you look at Java POJOs, there's so much going on in them that I think it's really hard to kind of see the forest from the trees kind of thing. You know, you get distracted by all the constructors and the two strings and that. And yeah, your like IDE can generate all that stuff for you, but still the cognitive load of looking at that code is pretty large. And when you see just a data class or a case class in Scala, you don't have to put so much mental energy into trying to understand what does this thing do? What's it for? What's it hold?
Well, and even just like we did the last few days, a friend and I did a developer retreat on Rust, which is much more interesting than I gave it credit for at first. But one of the things that I recoiled against was it had semicolons. And I just feel like, anything, it's like if you're going to be lazy about making a language, by making me put in semicolons, for example, I don't know, it immediately gives me, it's like, oh, okay, you're going to make me do work now rather than finding ways to remove my work.
I think it was you, or was it James? Maybe you, but you made a great analogy in a previous podcast about semicolons and this in general, where basically the compiler or the language is not respecting your time and it's not respecting your knowledge. And it feels that the developer, the person who wrote the compiler, decided to make it easy on them at the cost of making it harder for the user. And really, I think there is no excuse for a semicolon. Just write a little bit harder on your parser, make sure there is no ambiguities, and you can get away with not having any semicolons at all. I agree.
Mm-hmm. Yeah, and I don't remember how much we talked about it, but like type inference and having the type on the right, again, like that is you just look at the code and you don't have so much noise going on. So it enables, I think, type inference. I think we've had some discussions outside of the podcast about, can you do type inference with the type on the left? And I don't even know if it's possible, but it's just nice that Kotlin just puts it on the right, makes it look like most modern languages, and opens up the opportunity for type inference where you want it.
So should we go to you, because you had a list of points?
I've got the list pulled up.
Oh, you have a list pulled up. Okay.
Yep. So nullability in the language versus library supported was the first one.
Yeah, so so it's been a long debate between the people who prefer the Kotlin approach versus people who prefer the Scala/Haskell, and slash also you could maybe throw in Go and Rust also, which is doing the same thing. I've had strong opinions on all of this for a while. I understand the Scala/Haskell approach of using more. Well, let's talk about Scala. Haskell is a bit special, but Scala uses a library approach, which to me has the downside of being totally optional, which you never really need to use any of that. The compiler is not going to refuse to compile your code if you don't use that. You don't have to use option. You can just. Yep. So that's a downside. I understand the point of this is to be more universal, right? In that case, you're entering the world of monads, and you can have multiple monads and mix them together. Kotlin went a different way by special casing. We're just going to take care of null. First of all, we're not going to be universal. We're not going to be general. We're not going to tackle the other aspects or the other monads, just being able to represent the absence of value. But we're going to bake it in the compiler, which means the compiler is going to refuse your code until your code is null correct. And so that leads to the question mark and the optional dot and all that, which to me I think is a good representation of the philosophy of Kotlin, where it tries to make compromises that are pragmatic. Just all right, we don't need the universality of monads, but nullability is a big deal, and we have to deal with it because we're interoperating with Java. Whether you write just Kotlin or Kotlin plus Java, you're going to be dealing with Java libraries. So nullability is going to enter your world. So we're going to try to make sure that as long as you're just within the Kotlin world, as long as you've crossed over that border, once you're in the Kotlin world, your code is 100% null correct, and the compiler will not let you get away with anything less. So this is why I like when the language bakes that in, even if it's at the expense of something more universal, like a monadic approach that is library supported, like in Scala.
Yeah.
So I was thinking about it this week and realized that there are two cases with Kotlin. There's when you're interacting with Java and you get a null, that means let's say stuff has gone sideways, whereas within the Kotlin world, if you get a null, it means stuff happens. Like I asked for so it's like, anyway, that was an insight. At least I thought was an insight. But what about composition? Because it seems like with the nulls, you can chain things together relatively easily with null as a you didn't get the result that you wanted. But are we able to say, like, function f equals a applied to b applied to c with the Kotlin's null approach?
So to some extent, so now maybe we're beginning to talk about monads. We can switch to that. Just want to make one last point about nullability before we switch to that. As you, I'm sure you have, there are plenty of articles out there that talk about null and nullability and whether it's Kotlin or anything else. And most of these articles open with saying, oh, it's the $1 billion mistake, right? Horace said famously, the $1 billion mistake. I invented null and I'm really sorry about this. And I totally disagree with this. I don't think the $1 billion mistake is null. I think the $1 billion mistake is using null in a language that doesn't natively support it, that doesn't have a type system that acknowledges the existence of null and actually bakes it in and tries to handle it. And the
explicitness of it.
Null is a bottom type, which means it can be assigned to everything, and everything can assign to it. And this is the real problem. But Kotlin went the other way. It says, all right, null is a reality. And another reality is that we need to represent the absence of value. And what happens when you call something, you expect something, you don't get it, but it's perfectly normal, like a hash map, right? You're looking up a key, and sometimes there is nothing there. How do you represent that? You can decide to ban null, say, all right, my language is not going to have null, but you still have the problem, how do you represent the absence of value? And so Kotlin went ahead and said, all right, we're going to use null to represent the absence of value, but we're going to make it safe. We're going to make sure that you can never dereference this null. It's going to be a separate type of its own. So this is really what I like about this, is acknowledging that the billion-dollar mistake is not null. It's not accepting that null is a reality and that your type system should support it.
It's allowing you to make calls on something that's null is the billion-dollar mistake.
Well, yeah, I think the billion-dollar mistake is saying, well, how do we represent nothing, and how about a pointer of zeros? And then and then, as you say, without the language support around it, because, for example, Python has none, and that's not, it's not represented as zeros or anything like that. It's just a special object that you return when you don't have a result value, and it prevents you from dereferencing it, etc. So, yeah, but it's not taught well, I think, that concept. And so people can't look at it and go, oh, well, here's the null that causes a null pointer exception, and then here's the null that we use to represent not a value.
Exactly. I think the main point here is to separate these two concepts. Right? A null pointer is different from no value, and every language that doesn't acknowledge that is going to give you core dumps and crashes and stack exceptions and things, stack traces and things like that.
Mm-hmm. Okay, so what about monads?
Yeah.
So there's different ways that a language could deal with null safety. So, and like you said, Scala has chosen to use a monad, or allow people to use monads to represent this nullability, safe nullability. And Kotlin did it actually in the core language with syntax for it.
Yeah, so the idea behind monads, and I'm well aware of what you were saying in a previous podcast, where once you know monads, you become unable to explain it by law.
We haven't announced it yet, but our latest episode is all about monads and the curse of the monad, and can we overcome the curse of the monad and explain monads?
So I'm not going to try to do that. I think it would be bad. So the general idea is that how do you compose various functions that return various results, and how can you chain them and have the output of one come into the input of the next one? And monads are the general concept around trying to do this, and it does that by wrapping all these heterogeneous results into a structure called a monad that has two well-documented functions. This way, allowing all the function calls to be composed with each other. The idea is absolutely fantastic. This is something that we really want, right? We want something very uniform. It doesn't matter what your function returns. Whatever it returns should be able to be popped into the input of a next function, and you should be able to find an adapter. Monads try to do that. Monads are very successful at doing this in Haskell, but my experience with using monads outside of Haskell is that it's always very weird. It's never a very good fit. And it feels to me that monads is a lot more tied to Haskell than it is a universal concept. And also the fact that monads do not universally compose, which is something that blew my mind when I started realizing this. Maybe you can put the link in the show notes. I can give you that later. But many years ago, Tony Morris, one of the experts in that area, wrote an article saying monads do not compose. And I thought, okay, that's bullshit. And I started reading through this. I'm thinking, well, okay, I kind of see what he's saying, and he's right. And so at the end,
they don't universally compose. So you can compose monads, but yeah, they the back to the math part. Bruce and I I sometimes go the math way, and he goes the practical way. So I'm going to go the math way. So monads don't compose universally because they don't have a distributive law to them, and distributive is what you need to take two things and join them together. And so you can add functionality on top of monads that allows you to compose or join them together, but they join differently depending on what they are and the operation that you're trying to perform. So in the case of like option has a way to join with other options, and there's different ways to do it depending on the behavior that you're looking for. and same with like futures and tries and all. So most of the monads actually have ways to join them together, compose them. But where it gets a little bit harder is if you want to join two different types of monads. If you want to join a future and an option together, then you have to figure out a way for those two things to have a distributive law so that they can be joined. And this is where you get into monad transformers, and monad transformers are definitely icky. And so yeah, it's there. I could totally see that the monads on the surface, oh, what a great way to solve this problem. But then you try to do certain things with them and realize, oh, it's actually it's harder this way than not.
Yes, it was a very hard realization for me, because once I started understanding how monads work, I thought I had found the universal solution to most of my problems. And then I learned about monad transformers and about the fact that they don't universally compose. And suddenly I felt that I had been lied to. And it's not something that's talked a lot about, right? The fact that you have to start putting monad transformers into the mix when you want to start mixing them. Just when you think you're over the hump, say, all right, now I think I have a good grasp on monads. I understand all the main ones. I understand the hierarchy. I know functors. I know applicatives. I know monads. I know how they work. I can write the signatures in Haskell. And then, boom, you're thrown into the deep end of the pool and saying, all right, so now you need to learn monad transformers. That takes you one more level up. And then you realize, well, there are other things, such as it's very useful to learn how traverse work, for example, because you can use it very often and it's very convenient, and it allows you to do this kind of shortcuts that you don't have to use monad transformers for. So suddenly you feel, from a learning perspective, it was great. I feel that I kept exploring new things and learning new things, but I felt I was moving further and further away from trying to write code. Which I'm fine with, but I draw a separation between my intellectual pursuits and just trying to learn new things versus trying to write code and get things done.
Yeah.
But I think you said that in Haskell, it has the language support so that you don't have to mess around with things like monad transformers. Is that correct?
No,
You
you
still do, but
do.
Haskell has such a much more sophisticated type system, not just with hierarchies, but also with all kind of additional compiler switches that allow you to do a lot of things in a lot more elegant manner. Scala would be the second language that is closest to having a type system, but even in Scala, writing monad signatures is pretty painful. You have all the implicits that are coming into play. Overall, there is a lot of noise surrounding this when you try to port monads in a language that doesn't have a very sophisticated type system like Haskell, I found.
Mm-hmm. Okay, but back to my question about Kotlin and composition. I think you didn't completely.
Yeah.
So let me describe this one. So one of the places where I kind of found I think I found some of the limits of the way that Kotlin handles nullability is because nullable things are not monads. If you have two nullable things and you need to like chain the polling out, so let's say you have something that's nullable, which then you want to look up in a hash map that key, so that you've got the key which is nullable, and then you've got a hash map and want to get the key. If the key is set, then you get a nullable thing out of that. So you want to chain those two nullable things together. This is like a great place for monads, but with the question mark operator, you actually have to do a bit of boilerplate to do that proper chaining of those things, at least from what I've seen. Is that what you're referring to, Bruce?
Mm-hmm. Yeah. I just wanted his general overview on what the issues are when you're trying to compose functions in Kotlin.
So we lose a little bit in universality, and so we pay the price by doing a little bit more manual work whenever we need to compose. We cannot reuse the mechanisms that are built into monads, so we unwrap them or we recombine the types ourselves before passing them to the next level in the chain. From an intellectual standpoint, it's not super satisfying, but I found from a practical standpoint, it actually works okay. And I feel that the code that I write, when I'm trying to mix an unknowable ties with ethers or with futures or things like that, I look at my code in the end and I feel it's tractable. It doesn't have that much boilerplate, so I think overall the compromise was worth it. But I can see how someone who's used to writing Haskell and doing this in Haskell would not be satisfied with this kind of much more manual approach, whereas a lot of the mechanisms are already built in monads and they can just flat maps across multiple monads.
but it sounds like maybe you're saying the amount of effort. Well, for example, like what James was talking about. So in that case, you'd have to do a little extra work by hand, but you're saying maybe it doesn't happen that often, and when it does, it's not that bad. Is putting words in your mouth?
Yeah, that's my experience. And also in these cases, I can just come up with my own type. So basically, instead of assuming that I can pipe the output of one function into the input of any function, I'm going to write this little glue myself, just for this particular case or these particular cases. And I found that most of the time it works fine, and especially with some of the other libraries that have come up recently, such as RxJava and things like that, where they're doing quite a bit of groundwork for you to allow you to chain all these things, and they provide you all these operators that are already implemented for you. And so I found overall my compulsion to reach out for a monadic approach has lessened over the years just by leveraging all these mechanisms.
Okay. I feel complete on that topic. Do you, James?
I I definitely am on the side of I use monads and I'm so used to them that, like Cedric said, when I'm working in a world where I don't have the monads, I really feel the pain of it. And I'm like, oh, if I only had monads here, this problem would be easy. But I think they're, like we've identified, there's trade-offs on both sides, where when you're in the Elvis operator syntax, um, that syntax is really nice for like one set of problems, but then when you get into problems where monads are a better solution, then you feel the pain there. Whereas when I'm in monads, there's definitely a pain of, oh, why can't I just propagate the nullability down the chain, um, in the case of nullability. So yeah, so I think there's definitely trade-offs to both sides to it. What I think would be interesting is, like, is there a way that we can do both? Like, is there a way that you could use the question mark operator more generally and have it so you could get the benefits of both? Like, could you apply the question mark operator to monads and to hide some of the complexity around the simple cases for monads or something? I don't know.
That's,
Interesting.
yeah. It seems like that. I think that would be challenging. So as you know, James, I'm sure you already use them, and you mentioned it in a past podcast. There is Arrow on Kotlin
Yep.
for those of you who really want to dive into this. And Arrow also shows my point earlier about the fact that when you don't have a sophisticated type system, implementing monads is pretty gnarly.
Yeah, the higher kind of
Rather
type,
than
the
just
lack
use
of higher
Arrow.
kind of types.
Yeah, and they've done a fantastic job. I think they're pushing the limits of what the language can do, and they have a bunch of extensions
Yeah.
that they want to add to Kotlin to the type system for this. But back to your point, the question mark and the nullability is so baked in and so hard coded into Kotlin that I don't think it can be a part of the picture. If you want to have a more monadic world in Kotlin, you need to get rid of, not use the question mark, because it's doing a lot of things such as shortcutting, right? With
Yeah.
monads, you can do some shortcutting, but actually, when you start taking a direction through the composition where the weaving of the value, one of them becomes none or becomes empty, the evaluation continues, right? You're still continuing to evaluate every single step along the way, except that most of them are going to be knobs, something like that.
Yep.
Nullability is not that. It shortcuts right away, just like a Boolean expression. When you do a false and boom, the rest is not evaluated. So I think the question mark is a totally separate thing that we need to separate from nullability. It's not the
Well said,
management.
Tina.
Sorry, it's not the management of optional values.
Mm.
Yep. Yeah.
Um,
The other thing on this topic that I wanted to talk about is Scala 3 actually is um, going to, by default, represent nullables as a ADT. So we've talked about ADTs on a past episode, and so the representation of nullable values from Java APIs will be value or null, essentially. And what's interesting about this with Scala 3 is that that's not a monad. That it's much more like the way, I think it is the way that the Kotlin essentially represents these types, and are very similar to the way that Kotlin represents these types. And so when you are interacting in Scala 3 with a nullable that's an ADT nullable, you don't get all the benefits of monads and options, because they're not options, they're ADTs. So it's going to be interesting to see how that works in Scala 3. And when people use option versus when they use an ADT to represent this.
I really like this approach. I think we need to give a special mention to Ceylon there, because it was the language that really put this front and center. The fact that you can say a type is not, it's a or no, basically, and this is the type. Like, and you touched a bit on product and some types in the previous podcast, and I thought that was super interesting. And it gives you a nullability really fitting very neatly in the type system, whatever type system you have. As long as you start supporting some types, you can have this kind of thing, and nullability flows freely from that. So Ceylon went very, very far with that. The language itself failed, but I thought that was probably the most interesting thing about it. And I've seen that Scala 3s are heading this way also. I think it's a very interesting direction to explore.
Yeah.
So I want to talk about another topic on your list, which is build systems, because I just ran into yet another problem with Gradle, and so I'm kind of tearing my hair about it, and so I'm ripe to complain about build systems. And you built one of your own, so I want to hear your perspective on that.
Yeah, I've been interested in build system for a very long time. If you're a developer, you cannot not. You have to deal with the build systems, and you develop a love or a hate relationship, sometimes both. And more recently, Gradle for the past 15 years. Gradle started, maybe even 20. It's been a very long time now. It went on the heels of Groovy. So James announced Groovy maybe 2004 or 5, and Gradle followed shortly after that. So we're talking about, I think, easily 15 years. So very old build system, and it's become the standard pretty much on Java. I had to deal with it, and I've always had problems with it. Sometimes there are technologies that just don't seem to sink in for me, despite all the hours that I spend on it. The Gradle documentation looks fantastic, but each chapter is 50 pages, and there are 30 chapters. I honestly can say that I've read it all. I've read the whole thing. And I felt that even after reading it, I still didn't know how to write a build file. I was still reaching out to Stack Overflow and copy pasting all the time, trying to write my build files. I don't know if that's how you feel too.
Exactly the same. I read all this stuff, and I'm going, and none of it didn't cohese. It was just a bunch of, well, you do this and you do that and you do that, and I couldn't find an overarching theme that would allow me to go, oh, I know how to solve this problem now.
It seems like all build systems are created with a mental model underneath them for how the structure of creating and running the build. And after working with Gradle for many years now, I still don't understand the mental model that's underneath Gradle. And I still get tripped up on what's actually happening from the definition of my build file to this thing actually running.
It seems like there's a lot of magic.
It turns out to be pretty easy to read, which I think was the main goal. This is what the authors decided. We want something that's pretty easy to read in a programming language, and I think they achieved that, but we lost the capacity to write it. And I think they added a lot of very, very weird quirks. When I realized, all right, Gradle is based on Groovy, and I know Groovy, so I can write some Groovy code. It felt great. I can now write some code in my build file. Not always something that you want, but my impression of this is that the build file should be 90% declarative, but you should have this 10% available to you whenever you need to write some code.
You need to have the escape hatch there for when you need it. And you've experienced the pain of Maven when you need to get beyond the declarative side. You're in the world of plugins, and oh my gosh, it's not an easy step from declarative POM to plugins. And so
I think
that having the escape hatch is nice.
I think the fact that all three of us, who I'm going to go out on a limb and say, well, we're all pretty good at figuring things out, all have the same problem with Gradle. I think we have a quorum here.
Yeah, that's interesting. We're all pretty versed in languages and learning new languages and learning new concepts, but for some reason, Gradle has resisted us. The fact that even the simplest Groovy, I thought, all right, I know Groovy, I can write a function, I can declare a global variable, which I'm going to reuse across all my build or Gradle files. Well, even that doesn't work out of the box. You need to put your variable in a certain, .ext area. It needs to go maybe in a settings.gradle place in a specific directory. And even that, the rules, it doesn't work when it goes into build script. It only works when it goes in the main body.
And then when you try to convert that from Groovy to Kotlin, which I did recently, then you are on Stack Overflow for a solid number of hours trying to figure out how to convert just that little piece to Kotlin.
Mm-hmm. Yeah, I've gone down that path. I still think it's worth it. Overall, I'm pretty happy that all my build files now are Kotlin, KTS, great old Kotlin. It was painful to get there and to understand what are the, how do you automate, translating a certain idiom to another one, because Groovy is so dynamic that it's like jelly, well, no pun intended with the language, but it's so amorphous that you don't really know how to do it, and the build files have strings that are turned into functions that have some implicit calls that happen. So Kotlin puts a lot of structure into that, and it automatically buys you autocomplete in IDEA. And auto navigation and all that. So that was an immediate benefit for me. So back to your question, yeah. So before Kotlin became adopted as an official language for Gradle, I had the same idea. I thought, all right, I'm getting, I'm very tired with Gradle. I love Kotlin. I'm going to write a Gradle-like build system in Kotlin that implemented in Kotlin, but using the DSL as Kotlin as well. So that product is called Cobalt, K-O-B-A-L-T. I haven't worked on it in 2 or 3 years now. It hasn't taken off. I didn't think it would, but it was a super interesting exercise for me to learn how to do it. And I was really excited to use it. I was looking forward to using it. Of course, I created it, but not just that. Just the fact that everything worked as I was hoping it would. Now, I start a new build file, I start autocomplete, and IDEA shows me all the functions that are available, and my build files are very compact. I can really use Kotlin. If I want to declare a constant, I just put a val constant at the top of my build file, and it's visible across all my build files. I don't have all these weird quirks that Gradle put on us. I wanted to write on the plugin system also. The plugin system of Gradle is interesting in the sense that it's basically opening up the entire engine. You want to write a plugin in Gradle, you just have access to all the internal core structure and all that, and you can do anything you want. But of course, sometimes it's a bit weird to compose them. And I wanted to go the other way around. I had some experience with the Eclipse and IntelliJ plugin system where it's the other way around. Everything is well structured. There are endpoints that you can extend, and the whole system is very well contained. You know exactly when your plugin is going to be called and what you need to supply. So I built my plugin system around this, and I thought it worked really well, and it made the whole plugin system a lot more tractable at the expense of I have to expose these endpoints. I cannot just say, here is the engine, call me, do whatever you want with me. It's no, you can only call these specific endpoints, but at least they're documented, and I know exactly when I call you, and I know exactly when you call me. So
more of the Maven model of having a defined lifecycle and allowing specific points for plugins to interject into those parts of the lifecycle. Whereas Gradle is just anything goes. Mm-hmm. Which is part of, I think, what makes it complex and hard to understand and deal with is there is a life cycle there, but it is completely open. And so it can be really hard to understand when does this thing happen and why does this thing happen and what caused it and that sort of thing.
So my impression has always been that the essence of a build system is something to manage dependencies. And then everything else is kind of like a programming language. Have I gotten it?
Well, there's like 100 other things that a build system needs to do. Like a lot of it is around running things, taking the output of those things and storing it somewhere, but then hopefully doing caching well. And that's something that Gradle's actually done a great job of, is caching results of these processes. And so that it doesn't have to rerun them, so that incremental stuff is really fast. So yeah, there's dependency management, but there's also running things and taking those outputs. And then there's reports, like you want to be able to produce reports on either your dependencies or on your linting or on your whatever. And so that's again just running something and taking the output of it and storing it somewhere. But
I think you're onto something here, Bruce. I think the foundation of a build system is actually theoretically pretty easy, right? And it's a tree, it's a graph. You do a topological sort on this graph. Some of the tasks are strictly ordered, others not really, and those can be parallelized. We have inputs, we have outputs. Writing a core and an engine for this is pretty trivial. I've done it many times. Even TestNG does the same thing. When it's trying to run tests, it's just basically building a big graph of methods and just running them in a certain order. So I think that part is easy. But as James points out, the devil is really in the pragmatic detail. So first of all, the description language. How do you come up with a language where people can easily write new build files and they feel they have the power to account for everything? You want that build system to be hermetic. Ideally, you want to write everything in this build system. You don't want to start invoking Bash scripts or Python scripts or other things on the outside, because this makes everything much messier. So you want a description language which is easy to read but easy to write. And I think Gradle succeeds on one and fails on the other. I think you want a real programming language, like we said earlier. There needs to be an escape hatch. It's going to be most of the time not needed, but when you need it, it's useful to be able to, for example, having a class that builds something, you can just subclass it and just override a few things, and boom, suddenly you can build 5 different things, and they all vary by just one tiny thing. So using polymorphism or inheritance for this is super useful, I found. And then more pragmatic things, like you said, caching, distributed caching is super useful. Incremental compilation, being able to determine when something has changed, when something hasn't. Supporting the IDE, that's also something that a lot of build is completely overlook. And I don't know for you, but for me, even after 20 plus years of work in any IDE of Gradle, the groovy Gradle build file has never really completed well for me. There's always been errors in IDEA. They're not always the same. Sometimes completion works, sometimes it doesn't. It cannot find symbols. It doesn't put the red squigglies where it should. And with Gradle, with Groovy, it's never worked. With Kotlin, it works all the time.
That's right. Yeah, having a type system behind it is really nice. Yeah, I've used SBT, and there's some things about SBT that I really like. That I think are that some of them are in Gradle, like the type system for the build, the general language. SBT is just Scala, essentially usually use a declarative form of Scala, but SBT also recently added support for the language server protocol, LSP, I think is what it's called.
Yeah.
And so that enables tooling, mostly VS Code. So VS Code is based on or uses the language server protocol to get information about red squigglies in the IDE and all that kind of stuff. And so I think that it's really nice to have one build that is telling everything, all the information about, is this correct? Whereas IntelliJ and Gradle go a different direction. I'm sure that somebody's done LSP for Gradle, but IntelliJ is not using LSP. They use their own index and own logic, and so there's sometimes inaccuracies between the reality and what IntelliJ thinks is correct. And whereas it sure would be nice if my build was the source of truth for that information, because it is the source of truth when I run my build. So yeah, I think that's one of the things that the SBT is getting right, and some of the other build tools are starting to use. So yeah, I don't think we haven't found the build tool yet. We're still like, Gradle's fine, SBT's fine, but they're the best one. Maybe it's Cobalt. Cobalt, is that the name of yours?
Yeah, that's the
but I don't think we've found it yet.
No, it's to me it would be Cobalt. And again, I'm trying to detach to the fact that I created it, therefore I like it, versus I think it's a good tool. I honestly think, I've created tools which I think were not great overall. I think this one is good, and this is where I think that the design should have gone. Some of the syntax in there is really pleasant. The build files are very short, but of course it didn't take off because you cannot take on Gradle. And again, it wasn't the point. And most of the libraries or projects that I've created, I've never planned on taking over the world. I was just wanting to push the boundaries and try to explore a few things and try to fix some of my own pain points and see where it leads me. And I think Cobalt did that. And now I have a good idea of what I'd like a build system to be. But Gradle is close, but I don't think it can get there because of all its legacy. And even in Kotlin, when you write Kotlin code on your build file, you're still suffering from all the legacies and all the intricacies that Gradle has developed organically for the past 20 years, and they cannot get away from that unless they completely revamp the tool, which maybe at some point they will.
Yeah, for me, one of the biggest challenges with Gradle is the mutation that's happening underneath the covers that intertwines with the life cycle. And it's one of the, like, I hate mutability. It just makes everything so hard. And that's one of the places where I really prefer SBT, is that you certainly could do mutability, but you're in the world of Scala, so no one does. And so because everything is immutable in SBT, it's really easy to go in and inspect stuff. So there's a SBT console you go into, and you can then inspect the values of everything and know exactly, like, okay, here's this value, here's here it was set to this, and now it's not going to change. And so that's one of the things. The immutability of SBT is one of the things that when I'm in Gradle, I'm just like, oh, I can't understand what's happening here and why.
One of the other points that you made was you asserted that checked exceptions are great. So I want to hear about that.
Oh, let's talk about error handling and checked exceptions.
Oh yeah, it's only going to take us 6 hours for the entire. Well, so the concept of checked exception is great. I really like the idea that the compiler is going to refuse to compile your code until you can prove that you've considered all the error cases. That's really all I like about checked exceptions. That's really this. It doesn't mean that you need to do something about the exception. You can ignore it, and most of our bad programs or bad programmers would tend to do that. I was having a tweet discussion actually just recently where someone was saying, well, I did a quick survey of the code base at work, and most of the catch sections are empty. So therefore, checked exceptions are bad. I said, well, no, you're never going to stop people from writing bad things, but it doesn't mean the concept is not good. I said, no, it's not true. What check exception did to these programmers, even though they decided to write an empty clause, they had to put that empty clause in. They had to think about it, say, oh, what happened? And they decided to throw their hands in the air and to do something crashy that is bad for the software in the future and to do nothing about it. But checked exception forced them to pause and say, okay, this can fail. What am I supposed to do? I think
part of that, the reason for people ignoring them, is that checked exceptions in some ways were overused for in places where they shouldn't have been used. And so then it's like, oh, I'm just going to ignore this. Whereas if you're going to propagate an error to your caller, then it should really only be something that they can recover from. And that's the only reason to propagate that error.
Yeah, well, that was the point of exceptions in the first place, was recovery. And then much later we discovered that, the actual possibilities for recovering are really rare. It doesn't happen very often. But in the meantime, we started throwing exceptions all over the place.
Yeah, so I think what's really a bit disappointing to me, and what irks me when people talk about checked exceptions, is that first of all they tend to use the way they were implemented, or the way they were used in Java as the example of checked exception. They looked how checked exceptions are implemented in the libraries in Java. They see it's horrible, and they say therefore checked exceptions are bad. So I think first of all it's a little bit limiting to do this. Again, just because you misuse a concept doesn't mean the concept needs to go away. But I think on top of that, Java, the language, did not really give the tools to people who write code in Java to really fully use checked exceptions. The way I look at it, you shouldn't, the fact that an exception is checked or runtime is not tied to the class itself. So for example, file not found. Sometimes file not found is recoverable, right? The user, you open a file dialog and the user picked a file, but that file disappears and boom, it's no longer there. That's recoverable. You just ask the user for a different file. But there are cases where file not found is fatal. For example, you start your app and you expect a file to be part of your distribution. You try to open it, it's not there. Your app is dead in the water. You cannot do anything. That's unrecoverable. And so my point here is that file not found can sometimes be recoverable, sometimes not, which means that the language should let you decide. Whether it's the caller or the callee, I don't know. That's open for debate. But basically, you cannot tie the type of the exception to the class itself or to the value that it represents. It's really it needs to be a lot more fluid than that. And when you start looking at this way, then you realize, all right, so whenever something is recoverable but it can fail, it makes sense to put the programmer's nose in it and say, look, I'm not compiling your code until you tell me what to do here, because I know you can recover. So please recover. Don't put an empty section here, but recover nicely, and then I'll compile your code, and you will have code that is guaranteed to not crash.
So my programming style lately is evolved to basically be checked exceptions, use checked exceptions for these recoverable error conditions, but I do it with monads instead of with checked exceptions, and so I do. I am letting the compiler enforce that that is handled, and of course, like the caller can ignore that and decide to move on, but at least they have to consciously make that choice, just like with checked exceptions.
I guess with your example, and maybe, you know, maybe it's not an example that's going to survive this. I mean, I'm going to look. It seems to me like the programmer needs to check to see for the existence of the file before they try and do something with it. And so, to me, that's like, oh, well, this is a programming error. You need to see if the file exists, and then if you try and open it and it doesn't exist, then I don't see how you'd recover from. I mean, that's something happened in the operating system level. So maybe there's a better example that gives you, you know, makes a compelling reason for it.
For checked exceptions,
Well, yeah, I mean, well, or an exception at
just
all.
the difference between recoverable and unrecoverable.
Yeah. There's that, and in this case, I'd say that, well, that's a programming error, because you want to say, you want to check to see if the file's there before you try and do something with it.
Well, and I think what we've done in our programming model is that we have combined a bunch of different concepts into one general thing of exceptions. So we the exception doesn't. There's errors that should just crash the process. There's errors that we want to like propagate to the user, and then there's errors that we can actually recover from. And we've tried to like shove all that stuff into a
And
concept of
there's
exceptions.
programming errors.
And programming
That's
errors.
that's the fourth one. Yeah.
So in my use of what's called bifunctor IO, where I have a monad that has an error or a value, in that programming model, you can make that error extend from runtime exception, or you can actually use ADTs. And ADTs become a really nice way to represent these possible errors. So it could be that I call a method and my error return type is file not found. Well, let's say it's not the file not found exception, just a case class file not found, or so using ADTs, say, or parse error or something else. And so then my error type is actually composed of the or types that it could actually be, and that usually allows me to convey much more semantic information to the caller around what it's not just an exception. It is conveying semantic information about how they could potentially recover or retry or return the error to the user, or whatever it may be.
Mm-hmm.
Yeah, so I agree that this approach at least matches exceptions on that level. So whether it's bifunctor or either, I'm assuming you're referring to either, or some of the monads,
Neither,
you call a function, it returns this more sophisticated value that wraps things, and you cannot just move on with life. You need to deconstruct or pattern match in order to do this.
Yep.
First of all, by the way, you can do the same thing as you can with checked exceptions and empty braces. If you can you can still pattern match and just ignore the error case. So you can do bad things on both ends, and it doesn't mean the concept is bad. I think the concept is sound. So the problem, the reason why I think that overall exceptions are still better, even though they're less composable than this, is that when you do this, now your value is captured and it's wrapped into something. Right, it's a monad. You usually don't have direct access to it. Whenever you want to manipulate it, you need to flat map on it, your bind and stuff like that. And I find overall this obfuscates things, and it makes the code more complicated down the line, especially when you start composing this with other monads. What I liked about exceptions here is that you deal with naked values. You call something, you get the value you want, and if that value cannot be returned to you, the exception is going to send the code path on a totally different path. But it's away from you and you handle this separately. But your code, if a value was returned, you know that value is correct, and you can manipulate it directly. You don't need to go through flat map or anything. It's there for you to inspect and play around. And from a performance standpoint, also, if you have box types and things like that, the fact that everything is boxed into things adds up overall. Even though we have JVMs now that are a bit better, but overall, this is where I still feel a bit icky about this idea. I'd like to deal with naked values. I want my lunch and I want to have my lunch and eat it too. I want naked values, but I want also the compiler to keep me honest. And whenever they cannot give me that naked value, they force me to deal with the error.
So in your Kotlin programming, do you use checked exceptions and
No.
methods will?
Well, they're not there, right? So
Kotlin doesn't support checked exceptions.
Well, yeah, it hides them and it makes them disappear. It's like magic. There is one thing that I accept when people say, I don't like checked exception, because most people who say that what follows after because get it wrong. There is one thing where checked exceptions are not good at, and this is the reason why Kotlin doesn't support them. It's for composition. It's for when you have multiple functions, 4 functions, and one in the middle throws a checked exception, and then suddenly you cannot compose unless you start breaking your chain and starting caching and all that. So this is horrible. And this is the reason why checked exceptions are not working in this particular case. And that I accept, but I never hear people say that. It's really funny.
I know I hadn't thought of that until you just said it, but yeah, that's a really compelling argument.
This is the main reason. The JetBrains folks understand very well the value of checked exceptions, because they just realized that it wasn't going to work very well with the programming model they were pushing for with composition.
Mm-hmm. You also talked, and because James was ranting about this, so the builder pattern. You had a comment about the builder pattern.
Yeah, so it's a little tiny thing, really. I don't think it's as deep a topic as the ones we've just covered. But at some point, I think, James, you said that thanks to Kotlin and default and name parameters, you no longer needed the builder pattern. But before we go further, I want to make sure that I captured what you meant well.
So in Scala, we don't ever really use the builder pattern because we have named and default parameters in the constructors. But in the Kotlin world, the builder pattern is still used quite a bit. At least the what's it called, lambda. What are those lambdas called? The way that we do builders in Kotlin. It's the extension lambdas or whatever.
Extension lambdas or lambda with receiver.
Lambda, yeah.
Well,
and so the builder pattern gets used quite a bit still in Kotlin, but via that. And so, but I don't know why in Kotlin that we need that necessarily.
So what I don't understand is that Scala and Kotlin, so we can leave the DSL part because the way you implement the builder is not really relevant here. The point is the feature, which is name parameters and default parameters. Scala and Kotlin do the exact same thing here. So I don't understand what Scala does that Kotlin doesn't, or why Kotlin is that disadvantage.
Maybe it's a cultural thing, or maybe there's some syntactical difference or something for why the builder pattern gets used, or maybe it's because the Java people are used to writing builders, and so that seems like the natural way to go. But I see, like definitely Kotlin, you see a lot of builder pattern stuff going on.
So
and in Scala,
my experience with it was that if you want to create a complex, I don't know, say a map of a complicated map which is all immutable, or read-only, I guess they want me to say, because they're still working on immutable data structures. It can get really difficult and messy if you don't have some. So if you have the builder pattern, you can say, okay, I'm going to do some mutability inside the builder pattern, but then what I'm going to return is a read-only or immutable thing, and it makes the coding easier. So
my take on this is it's not about immutability. I think you need the builder pattern when before your object can be constructed, it needs to make sure that a certain subset of parameters was passed and they contain the right values that are compatible with each other. It's something you want to avoid overall, right? You want to avoid objects that are hard to create, but once in a while you have an object that can only be created if you have a first name and a last name, and an age, or a gender, this kind of thing. Once in a while you encounter this. And when you have this, you have to have some validation logic, and this is where the builder pattern comes in. And I think it is independent of language. In some way, you're going to have to invent this and implement it in Scala or in Kotlin or anything. You're going to have to validate the arguments. To me, the builder pattern is really just that. It's going to make all these safety checks on all the parameters. And once it's happy, once it knows that it can create and instantiate an object that is well formed, then it does so and it returns it to you. Otherwise, it fails. So that's why I didn't see the parallel between builder pattern and default and name parameters. I don't think they're related.
Well,
So maybe it's more that like in Scala, you can do an apply function where you specify the data structure that you need in your apply function in the way that you need them. And maybe that's more of the difference is the ability for a constructor like syntax that can express the things that you need to validate or whatever.
But apply is just the parenthesis, right? It's just the invoke. That's
Right.
all it allows you to do, right? It just allows you to take your object and call a parenthesis, and it's going to call apply on it.
Yeah, so in your use case of, let's say you're constructing a person and you must have a first name and a last name and an age or something, then I would just make sure that my constructor requires those parameters to be passed.
there's something here that, I mean, like the builder pattern is about multiple steps. That's the essence of it.
But that requires mutability, right? And so I think that's the connection with so in Scala we just never use builders because they're mutable and mutability is yucky. and I don't know why we can't have that same way of doing things in Kotlin. And so
Well,
maybe it's just purely cultural or
because I had this example where I was doing the right way of constructing this immutable map, and it was complicated. And Svetlana said, "Oh, we have the builder pattern now, so maybe you shouldn't even include that example." And I can't even remember now whether we did include the complicated way versus the builder way.
I like to, yeah, if you can find that example, I'd be curious to see what you were working on. But I don't think builder is about steps. It doesn't really matter in what steps you set things, in much the same way that when you have name parameters in Kotlin or in Scala, you call and you assign each parameter to its value in any order. It doesn't really matter. What matters is when it comes the time to instantiate, then this is where the validation logic kicks in. And it's going to collect all the arguments that you pass, and it's going to run some rules, make sure that they're consistent with each other, and then instantiate or fail.
Okay. Let's see. The
So I think
intent of the builder pattern is to separate the construction of a complex object from its representation.
That's an interesting way of looking at it.
I'm just reading this off of the Wikipedia page.
Yeah, I guess then the representation would be of the various steps where you pass, this argument equals this, that argument equals that, this argument equals this. So that would be the representation.
No, that's the construction.
But the construction to me would be instantiation. That's when you create the object. This would be just how you specify the object. I don't know. I'm trying to understand what they mean by that.
Mm-hmm. Yeah, because I had always seen it described in terms of having multiple steps, but here's another one that says construct complex objects step by step. Maybe that's where I got it from.
So I have an example of this actually, where I was working with in a Kotlin build file just yesterday, and there was some parameters that I needed to pass to Graal VM. So there was options. It was an options mutable list or something like that. And in the Gradle Kotlin DSL, the way that you would add multiple parameters is say like option and then string, your option that you want to pass, and then you'd say again option and then string and then option and then string, and then each time you call that, it was mutating the underlying thing to build the options. When I initially was trying to write this build, I was trying to set options to a list of all of my things, and it's true that like it didn't look as declarative. where, instead of saying option, 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 it was option equals list with all my options. And so it didn't, so the immutable Scala developer me was trying to do it the immutable way. But the way that the author of this particular Gradle plugin had intended for it to be used was the mutable, the mutable way. And so I don't think that they certainly could have had me do it the immutable way, the non-buildery way, but they chose not to. And so that's where I wonder if it's really just cultural that we use builders instead of using constructors for things. Because I think in Kotlin we don't need the mutable builders.
It's still I think it's not a full feature yet. You have to put a experimental tag on it or something to that effect to get it to compile.
Yeah, and I think in Scala, I can come up with an object that's a bit complex to build, and you're going to implement it. You're going to re-implement a builder pattern in some way. Maybe it will be a little bit more immutable than the Kotlin version would be, but the builder pattern it's a design pattern, I think, for a reason, which means it kind of transcends multiple languages. It's something that you need to do now and then, and so it's good to capture it. But I'm pretty sure I can challenge you on that, James. And if you say, well, look, in Kotlin, here is a builder pattern, and here is how we do it in Scala. And if I look at the equivalent code in Scala, I think it will look a lot like a builder pattern, just with Scala syntax.
Oh, I like this. Okay, we'll do this. We'll do this afterwards. This will be fun to see. Can you force me into a place in Scala where I really need something that looks like a builder pattern?
Nice.
That'll be fun.
Okay, the builder challenge.
The builder challenge.
Nice. I think we're kind of out of time, right?
Yeah, I think we got through all of the topics that we wanted to get through. So.
I believe we did.
Okay. And we went deep on some, but we barely touched a few others too.
Mm-hmm.
Well, that was super fun. It's great to talk with you, Cedric. I learned a lot.
Thank you very much, guys. I really enjoyed this.